So in the last class, we have discussed with the inter-process communication. So there is a various forms of the inter-process communication that is on off duplex mode, FIFO, full duplex pipe, named full duplex pipe, message queue, shared memory, semaphore, sockets, and as well as the streams. So now we'll go to discuss with the in detail with the pipes. So what do you mean by the pipes? Okay. So here the pipes are the oldest forms of the Unix operating system. Okay. So the pipes have the two limitations. So that is a two different limitations of the pipe, that is historically they have been off duplex. Okay, so that is the data flow is the one direction. So the data can be flowing only one direction. We're going to call it as a off duplex mode. Okay, some systems now provide the full duplex pipe, but for maximum portability. We should never assume that this is in the case. Okay, so here the pipes can be used only between the process that have the common ancestor. So the normally pipe is created by the process that the process will going to call the fork function. So here, so the pipes are the oldest forms of the Unix system. The pipes have the two different limitations. Okay, so off duplex pipe are the most common used form of the interprocess communication. So that is the data flows in only one direction. Okay, the data flows only in one direction, that will going to call it as an off duplex pipe. Every time you type a sequence of commands in a pipeline for a shell to execute, the shell is going to create a separate process for each command and the output of one of the input of the pipe will be missing. So here, whenever you're going to need to execute any of the shell programming. So what will at every time we're going to type the create the different separator process for each of the commands and links standard output of one of the standard input. So this standard output can be given as an input for the next command. Okay. So here a pipe is created by the following pipe function. Okay, so the int pipe followed by the int that is within the bracket. So that is int, and again we'll go into with the file descriptor of 2. So here file descriptor of 2, it is nothing but the file descriptor of 0 and the file descriptor of 1. So it will going to return the value 0 only if it is okay, or it will going to return the value within a 1. Okay, so the two file descriptors are returned through the file descriptor argument. There is a file descriptor of 0, it is open for reading, and file descriptor of 1, it is open for writing. So this is a diagram. So how the full duplex mode or the full duplex pipe will going to make with the two ways. Okay, so here file descriptor of 0 that can be connected to the file descriptor of 1 with the 0, and in the user process file descriptor of 1 it can make the communicate with the pipe within the kernel. So the name itself indicate the 0 is open for reading purpose and the 1 is open for the writing purpose. So this is about the half duplex pipe in the fork. Okay, so here a pipe in a single process is next to the useless. So here normally we are going to call the fork function. Why we are calling the fork function? The parent will make the communication to the child process. Okay, so that is file descriptor of 0 with the file descriptor of 1 that can be make the communication with the pipe. Okay, so here the vice versa, and again this file descriptor of 1 if it need to communicate with parent process, that is a file descriptor of 0. So the common method it is using as a pipe method. So here only a single pipe we are using, that is a descriptor of 0 and 1 with the communication with the parent and the child process. File descriptor of 0 is open for the reading process and file descriptor of 1 is open for the writing process. That is a pipe from the parent to the child process. So here for any of the pipe from the child to the parent, so the parent will closes the file descriptor of 1 and child will closes the file descriptor of 0. So this is how the communication will take place between the parent and as well as the child process. When one end of the pipe is closed, the following two rules will going to apply. So which are the following two rules? If we need to, or if we read from the pipe whose right end has been closed, read it returns 0 to the indicate an end of the file after all the data has been read. Okay. If we need to write any of the data, or if we need to write any of the data, any one side of the pipe needs to close and one side of the pipe needs to open. Okay, if it has been closed, then it will return the value that is 0. If it has been open, then it will going to return the value that is a sick pipe. It can be generated. If we either ignore the signal or I can catch the signal, so it will return the value. It returns only one with the error number, that is EPI PP. So this is what the important program, and this is the code, which is the important code to create a pipe between the parent and the child to send the data down the pipe. Okay, so that is file descriptor of 2. It is nothing but the file descriptor of 0 and as well as a file descriptor of 1. And the character, it is taken as a maximum line. If the descriptor of 0, if it is less than 0, then error will be created or error will be given. If that write file descriptor of 1, so that hello world can be printed. So if any need to standard out the file name, so the different maximum file values can be printed or it can be set. So on the next topic, that is the recalling the program tell wait function. So that we'll discuss in the next session.